everyone. So we're going to be continuing section 2.3 in this lesson. In this lesson, we're going to be looking at equations that have decimals. So go ahead and get your notebook ready and let's just dive right in. Go ahead and copy this equation in your notebook. So just as I showed you two methods of working with fractions, I'm going to show you two methods of working with decimals. What I will say about both methods is the same thing as last time. Choose the method you're more comfortable with and stick to that method. When I'm working with decimals, sometimes I like to use the alternative method, and sometimes I like to use the method where I just work with the decimals. I kind of just look at the equation and see what kind of numbers I'm working with, and then just kind of play it by ear. So method one, I'm going to show you how to work with the decimals throughout. I have two like terms that I first need to combine. They're both negative, so I'm going to add them. Now remember, when we add or subtract decimals, we line up the decimal points and then add or subtract down the columns. The decimal comes straight down in our answer. 6 plus 3 gives me 9. 3 plus 3 gives me 6. So this is a 6.9, and it should be a negative because both of these signs were the same. They were both negatives. Don't forget that the m comes out at front. Equals negative 9.9. And at this point, it's just a one step. I'm going to add that 6.9 to both sides. Let me line that up a little better. We want to line up our decimals. My signs are different, so I have to take their difference. The number that looks larger should be stacked on top, which it already is here. So now I'm just going to subtract down the columns. 9 minus 9 gives me 0. Bring down my decimal. 9 minus 6 gives me 3. Negative and positive, my signs are different, so I need to determine which sign to match. The larger number is the negative, so I match the negative. So looking at this, you should know that when a number ends in a decimal and then just zeros, that's the same thing as an integer. So this is really just m is equal to negative 3. So there's one way to work with the decimals. Fairly simple, not too bad. Let me show you the other method, which ends up clearing the decimals. Now, one thing about this method is sometimes it makes the problem easier, sometimes it makes the problem harder. For this particular equation, it actually makes the problem a little bit harder, but I'm going to show you the method anyways, because we may get to some equations where I'm looking at it and thinking, you know what, clearing the decimals would work out quite beautifully here. So it's very similar to clearing fractions. You're going to multiply all the values in the equation by a number that clears the decimals. That number that we're going to use is a power of 10. So by power of 10, I'm talking about numbers like 10, 100, 1000. It starts in a 1 and then just has zeros. To choose that power of 10, find the decimal with the furthest rightmost decimal point and choose a power that is similar to that decimal place. So when I look at each of these decimals, they all end in a tenths place. So the power of 10 that would be similar to that would be 10. So step 1, choose a power of 10, similar, hopefully I spelled that right, to the rightmost decimal place. So you're going to have to look at all the decimals to figure out which one that's going to be. And then step 2 is the same thing as step 2 when clearing fractions. We multiply every value by that number. So multiply every value in the equation by that power. So as I mentioned here in this first equation, all of the decimals have a tenths place. So the power that I want to use here, I'm just going to write it up here, is going to be 10. That's similar to the tenths place. So I'm going to multiply everything by 10, including that variable term sitting out front, even though it doesn't have a decimal. 10 times m, I can do that in my head. Now, when I'm clearing my decimals, the easiest way to do it is just take the decimal point and move it to the right, however many times we need to. To determine how many times you need to move it, look at how many zeros you have in your power. I only have 1 0, so I move my decimal points 1 time to the right. This 3.6 is going to turn into a 36 point. As I mentioned in the previous slide, if a number ends in a decimal point, it's really just an integer. So this 36 point becomes a 36. Same with the 3.3. It turns into a 33. I'm just moving that decimal point over so it's an integer. And then the negative 9.9 turns into a negative 99. The decimal's over here to the right now. So again, it looks a little more complicated than the one I did before, but it's still good to know this strategy, just so you have it. I'm going to combine my constants together again, just like last time. I've got some like terms. So the 10n comes down in my line of work. Negative 36 plus negative 33. So 36 plus 33, you should get 9 and 6, so I get 69, but it's a negative. Remember, you're matching these signs. This equals negative 99, and now it's a two-step. Add the 69 to both sides. My signs are different, so I'm going to subtract here. 9 minus 9 is 0. 6 minus 9 is 3. I match the negative because it's bigger. Last step would be to divide both sides by 10, and m is equal to negative 3. So we get the same exact answer. So I encourage you to play around with this new method to see if it's something that you prefer. We're also going to check our answer in this lesson. So we got that m was equal to negative 3. So everywhere I see an m, I'm going to replace it with that number. Everything else gets copied exactly the same. And on the left, I'm just going to evaluate. That's a fancy way of saying do the math and get it down to one number. Negative 3 minus 3.6, I'm just going to subtract left to right. Their signs are the same, so I'm actually going to add them together. So the 3 is really a 3.0, and I'm adding it with 3.6. 0 plus 6 gives me 6. 3 plus 3 gives me 6. My decimal comes straight down in my answer. They were both negatives, so remember, this is a negative 6.6. I'm going to bring down my minus 3.3 equals negative 9.9, and I keep going. Same signs again, so I'm going to add 6.6 with 3.3, and just make sure that I match the negative sign with whatever number I get. 6 plus 3 gives me 9. 6 plus 3 gives me 9. Decimal comes straight down. And this matches the number that is on the right. So that means we found the correct answer. Okay, here's another one to copy in your notes. Go ahead and copy it down. I'll walk you through. Now in this one, we have parentheses. We should always distribute first, regardless of what method we're using, whether we're working with the decimals or clearing them. So I'm going to multiply 3.5 with the 4. Remember, when we multiply decimals, we ignore the decimal. We pretend it's an integer. So I'm looking at this like it's a 35. 4 times 5 gives me 20. Carry the 2. 4 times 3 is 12, plus 2 more is 14. And now I need to adjust for however many decimals I need. I need to adjust for 1 decimal point. So I start by placing the decimal all the way to the right, as if I'm looking at this as an integer, since that's what it looked like. And then I move it to the left 1 time. So this becomes a 14.0, or in other words, it's just an integer. So this is a 14, and there's an x. 4 times 2 I can do in my head. That's just going to give me an 8, and this is equal to negative 45.2. So looking at this equation, the numbers seem pretty reasonable to work with without having to clear the decimals. In fact, I would prefer working with these numbers as opposed to multiplying everything by 10. I would know to use a power of 10 equal to 10, since this decimal, which is the only decimal I see, has a tenths place. If I cleared my decimals here, this would give me some pretty big numbers. This would become 140, this would become 80, and this would become negative 452. If you want to play around using that new method, go for it. We should still get the same answer in the end. But I'm just going to solve it as is. It's a two-step at this point, so I'm going to subtract my 8 first. Remember, this 8 is really an 8.0, and if I'm adding or subtracting, I need to line up my decimal points. Okay, so my signs are the same here, so I'm actually going to add them. 2 plus 0 gives me 2. My decimal comes straight down. 8 plus 5 is going to give me 9, 10, 11, 12, 13. It's going to give me 13, carry the 1. 4 plus 1 is going to give me 5, and then they're both negative, so I match the negative here. And then the next thing I need to do is divide both sides by 14. Okay. So I'm going to bring down my x here, and there's a couple of different strategies that you can use here. You could clear the decimals here and then get a fraction and reduce the fraction, or you could do long division and see what decimal we would get. Let me actually show you both ways real quick. So I'm going to do it using the skills that we know we have already, and just put the 14 outside and do some long division. That might require a little guess and check. So I don't know how many times 14 will go into 53. I'm going to try 4 to start off and see what that gets me. 4 times 4 gives me 16, carry the 1. 4 times 1 is 4, plus 1 more is 5. Too high, so let's try 3. This will give me 12, carry the 1. 3 times 1 is 3, plus 1 more is 4. So this is as close to 53 as I can get without going over. So I'm going to write my 3 over the end digit of the number I divided and write my product at 42 underneath and subtract. 3 minus 2 gives me 1. 5 minus 4 gives me 1. And I bring down the 2 to keep going. Well, 14 times 4 got me almost about halfway there. So I'm going to try 14 times 8. I'm just going to double that and see what that gets me. Might not be anywhere near what I need, but let's just see. 8 times 4 is 32. Carry the 3. 8 times 1 is 8. 9, 10, 11. Aha, there it is. So my 8 goes above the end digit of the number I divided, and my 112 goes underneath. My decimal point comes straight up into my quotient. Now, I didn't need to adjust for any decimals here before I started dividing, and that's because my divisor, the 14, was a nice integer. Remember, if you're doing long division and the divisor is a decimal, you have to move the decimal until it's a whole number. So I'm getting 3.8 as my quotient, and it's negative. So here's my final answer. That's one way that we could have gotten our answer. Or one thing we could have done, similar to clearing the decimals in the starting equation, I could have multiplied this number by the power of 10 to move the decimal point. But since I'm doing that to the top, just as anytime when we adjust a fraction, I could have done that on the bottom. This would have given me x is equal to negative 532 over 140. And then I could have just reduced this. Okay, it might not be super easy to reduce a fraction with these large of numbers, but this is a strategy that you can use if the numbers are actually small enough. You can just leave your answer as a reduced fraction if you want to. You don't have to make it a decimal. Let's just actually reduce this and see what we get. I'm going to try to divide it by 2 first. And that's going to give me, I can do the bottom one in my head. That's just going to give me 70. And the top number is going to give me 260. Here, let me just do it real quick. I don't want to make a mistake. Divide by 2. 2, bring down the 3, 6, write my 12, subtract, bring down the 2, 6. So 266, I can keep going still. I can divide both of these by 2 again and get x is equal, again, I can do the bottom one in my head. That's going to give me 35. I encourage you to do the long division if it's, too difficult. And the top number, I can actually do that in my head as well because every single value is even, so I can just divide each number by 2. 1, 3, 3. And I'm wondering if I can divide that number any further. I'm not sure if that reduces any further. It might, but I don't want to spend too much more time on this problem in particular since we already have the answer. But this is a strategy that you could use if the numbers work out nicely enough. You could clear the decimals at the very end, make it a fraction, and then reduce it. Let's go ahead and check that answer that we just got. We got x is equal to negative 3.8. And same thing as last time, I'm just going to replace everywhere that I see an x with a negative 3.8. Remember, these two values are being multiplied, so we want to show the appropriate operations here. Plus 2 is equal to negative 45.2. Okay, I have to do what's in parentheses before I do anything else, and I need to multiply in the parentheses before I can add in the parentheses. So I'm going to stack these numbers, and I'm ignoring the decimals, but it turns out it looks like I'm just stacking them anyways, but understand that when we multiply decimals, you're not stacking the decimals. They just do by coincidence here. 8 times 5 gives me 40, carry the 4. 8 times 3 is 24, plus 4 more is 28. Since I now need to multiply with this 3, I need to drop a 0 for my new row and keep going. 3 times 5 is 15, carry the 1. 3 times 3 is 9, plus 1 more is 10. Add down the columns, 0. 8 plus 5 is 13, carry the 1. 2 plus 1 is 3, and the 1 comes down. I need to adjust for 2 decimal places, so I start at the right and move 2 places to the left. I can ignore this ending 0. So this first value here is just going to be a negative. Don't forget there's a negative there. 13.3. And I bring down my plus 2. I'm copying everything else exactly the same because I haven't done anything with those numbers yet. My signs are different for these values, so I'm going to subtract them. So that means I need to stack the number that looks bigger on top. The smaller number goes underneath. And I need to add a decimal and a 0 so I can line up the decimal points. And I subtract down the columns. 3 minus 0 gives me 3. 3 minus 2 is 1. 1 minus nothing is 1. And then I bring my decimal straight down. So this is 4 parentheses. This has to be a negative 11.3 because the larger number was negative. Oops, dropped my negative sign by accident. And the last thing I need to do is multiply this 11.3 with the 4. So I'm going to do that off to the side here. 11.3 times 4. 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus 1 more is 5, and 4 times 1 is 4. So again, I'm ignoring the decimal and I'm pretending it's a 113, and now I'm adjusting for the decimal at the very end. There's only 1, so I start at the right and I move 1 place to the left. So I get 45.2, and different signs give me a negative product. We match, so there's our answer. Okay, one more that we'll do together. So same thing here. Before we do any method, regardless if we're clearing the decimals or not, we need to distribute. The 3 is only going to get distributed to the terms in the parentheses. This negative 2.8 is just going to come down for the ride. So I'm just going to copy everything else here. 3 times 2.6. I'm going to do that off to the side. I'm not lining up my decimals because I'm multiplying. 6 times 3 gives me 18, carry the 1. 3 times 2 is 6, plus 1 more is 7, and I need to adjust for 1 decimal place. So this is going to be a negative 7.8, and there's an x. 3 times 0.6. Again, I'm just stacking them together, ignoring the decimal. 6 times 3 is 18, carry the 1. 3 times 0 is 0, plus 1 more is 1, and I adjust for the 1 decimal point. So this is going to be a negative 1.8. Both of these were negative since the 3 was positive, and these numbers were negatives. Different signs when we multiply give us a negative. And then I bring down my negative 2.8x. I've got a couple of x terms I can combine, and they're both negatives, so that means I'm going to add them. So I'm going to add 7.8 with 2.8, line up the decimals, add down the columns. 16 carry the 1, 7, 8, 9, 10 is what I get here, and I bring down my decimal straight down. I get 33.6, which is negative. This also should be a negative because my two negatives here, remember we matched the sign, and there's an x, and then I bring down my negative 1.8. I could clear the decimals. If you were going to use that method here, you would multiply everything by 10 because that's the rightmost value I see anywhere. But I think I'm going to work with the decimals again, simply because looking at this, I can tell that if I cleared the decimals, again, that negative 33.6 would turn into a pretty big number. It would turn into negative 336. I don't want to deal with numbers that large, so I'm just going to work with the decimals. It's a two-step. I'm going to add the 1.8 first to both sides. I'm going to line up my decimals. And since the 33.6 is the number that looks bigger, I can just go ahead and start subtracting down the columns. I'll need to borrow to make this 6 a 16. That's going to give me 8. 2 minus 1 gives me 1. 3 minus nothing gives me 3. And I match the negatives since that was the bigger number. Decimal comes straight down. Okay, and now I need to divide both sides by negative 10.6, and this is where it might get a little hairy because it's not going to be easy to do this division. So again, I could do long division, or I could clear these decimals, make them really large integer values, and just keep trying to reduce them. I'm actually going to take my chances and do it as long division. So the 31, actually let me erase some of this so I've got a little more space. I'll shrink it. I'm going to put the 31.8 inside my long division. The 10.6 goes at the door. Remember that this divisor must be a whole number, so I have to move it to the right one time, so it becomes a 106, and then I follow the leader in my dividend. So I'm actually going to rewrite this. Let me just move this out the way. It's going to become 106 and 318. Now you might be thinking these are really big numbers to work with, but I'm going to use my number sense and number logic to help me figure out what numbers to check. If I instead looked at this as 100 and 300, that would be a little easier for me to work with. I know that to get 100 as close to 300 as possible, I can simply multiply by 3. So that might be a nice reasonable number to try and start with to do my guess and check. I'm going to multiply 106 by 3 and see what I get. 6 times 3 gives me 18, carry the 1. 3 times 0 gives me 0, plus 1 gives me 1, and 3 times 1 just gives me 3. So there it is. I didn't even need to do that much work for this one. My 3 goes above the end digit of my dividend. I multiply, subtract, so I get a nice integer value here. So this works out as a 3, and it should be a positive because the negatives canceled out. Here's my final answer. You should have gotten the same thing if you chose to clear the decimals at this step here. This is where you would have cleared the decimals. Let's go ahead and check that answer. We got x is equal to 3, so I'm just going to write that up here. Everywhere I see an x, I'm going to replace it with a 3. Everything else stays the same, so times 3 minus 2.8 times 3. I'm going to multiply in this parentheses first before I subtract the 0.6. 2.6 times 3 gives me 8, carry the 1. That's going to give me 7. I adjust for 1 decimal point. So this is going to give me negative 7.8 since their signs were different. And then I bring down my minus 0.6. Oops, not equals. We just want it to read minus 2.8 times 3. Okay, so my signs are the same here. I still got something to do inside this parentheses, so I'm going to add these two numbers. So 7.8 plus 0.6 is going to give me, so that's going to give me 14. Carry the 1, that's going to give me 8. Decimal comes straight down, and it's a negative because I matched the sign of the things I added together. So we've got a negative 8.4 in the parentheses, minus, and I can go ahead and multiply this off to the side here because it's not really being affected by what's in parentheses over to the left. So I'm actually going to go ahead and do that now. 2.8 times 3 is going to give me, so that's going to give me 24, carry the 2. 6 plus 2 more gives me 8, adjust for 1 decimal point. So this is actually 8.4. And then I've got some multiplication to take care of here as well. I'm going to multiply, let me shrink some of this real quick. I'm going to multiply the 8.4 with the 3. That's going to give me 12, carry the 1. 24 plus 1 more gives me 25, and I adjust for 1 decimal point. So this is negative 33.6 is equal to a negative 25.2 minus 8.4. And last but not least, I need to combine these constants. They're both negatives, so I add them. 25.2 plus 8.4. I align my decimals and add down the columns. 2 plus 4 gives me 6. Bring down my decimal. 5 plus 8 gives me 13. Carry the 1. 2 plus 1 is 3. And remember, these two numbers were negative, so this is going to be a negative 33.6, which is what we were hoping to get because that was on the left. Okay, so I'm going to give you a few equations to try on your own. Go ahead and give them a go, and then I will pause the video, and when we both unpause, you'll see the solutions. Okay, so here are the answers that I'm getting for both. I decided to go ahead and clear the decimals for the example on the left, just so you could see that strategy being used one more time. When I look at these decimals, they both have a tenths place, so that's the power of 10 that I'm going to choose. I multiplied everything in the equation by 10, giving me the following equation. I combined my two variable terms. Their signs were the same, so I added and matched the negative, and then it's a two-step that I solved by adding the 32 to both sides. Signs were different here, so I subtracted and matched the negative since 97 is bigger. And then I divided both sides by 20. So there's a couple different ways you can write your final answer for this one. If you're clearing the decimals like I am, these are pretty small numbers and are fairly easy to reduce if I looked at this like a fraction. I simply divided both of the numbers by 5 and left it at 13 over 4. You can write your answer like that. You can leave it as a simplified fraction. Just because we started with decimals doesn't mean your answer has to be a decimal. Or you can do the long division, or if you're using the method where you're not working with clearing the fractions, the decimal answer that you would get is 3.25. The example on the right, I did not clear the decimals, I just worked with them. The first thing you need to do is distribute. My work for both of those products is right here. I'm getting negative 5.1 and a positive 8.7 because these two negatives end up canceling. Then it's a two-step where I add the 5.1 to both sides. Signs were different, so I had to subtract here. Notice how I'm lining up my decimals and I'm borrowing as needed. I got a negative 26.1. And then I divided both sides by positive 8.7. So when I set up my long division, I adjusted my decimals so that they became whole numbers. And then I just did a guess and check. So I'm using my number sense to help me figure out what number to try first. When I look at this, these numbers are pretty large. 87 and 261 are pretty big numbers. So when I look at this, I'm asking myself, well, what number am I going to multiply with 7 first? Because that's what I multiply with 7. Or excuse me, that's what I multiply first. I multiply with the 7. What number do I multiply with 7 so that it's a number that ends in a 1? Well, I'm thinking I can do 7 times 3, which is a 21. So I tried that first and I got lucky, and that ended up being my answer. Last thing, you want to make sure to go back to the original problem to adjust the sign of your answer if needed. So these were the last two problems. I hope that these examples helped you, and I will see you guys next time. Take care.